Welcome for online video session. Myself Jagadish, Associate Professor, Department of Computer Science and Engineering from Canara Engineering College, Banpal, Mangalore. Subject I am taking online session is Software Engineering 18 CS 35 VTU syllabus. So in this online video session, we'll see the third module, second chapter. In the prescribed textbook, it is 7th chapter. In the module 3 is a second chapter. So chapter name is Design and Implementation. So topics covered in this chapter: object-oriented design using UML, design patterns, implementation issues, and open source development. So coming to this topic, design and implementation team or implementation is a stage in the software engineering process at which an executable software system is developed. Software design and implementation activities are invariably interlinked, is a interdependent, or it's a number of stages. Software design is a creativity activity in which you identify software components and their relationships based on the customer's requirement. Software engineering is an implementation, is the process of realizing the design as a program. Design and implementation are something like closely linked. That should normally implementation issue is the account of developing a design model, whatever the model we have designed in the previous chapters or in the previous topic. And you can take an example, that's UML to document design may be the right thing for programming in an object-oriented language such as Java or C#, and it is less useful if you are developing in a dynamically language like something like Python or machine MATLAB, etc. And the important is the implementation decision has to be made at the early stage of the software project. So implementation has to be made at the early stage of the software project, is whether or not you should buy or build the application software. Once if you start developing the product without knowing the languages, then you may stuck up in delivering a product in time. You're not able to deliver a product in time to the customer, so which leads to in a trouble for the employee. In a wide range of domains, it is now possible to buy off-the-shelf system, that is COTS, that can be adopted and tailored to the user requirement. For example, if you want to implement a medical record system, you can buy a package that is already used in hospitals. It can be cheaper and faster to use the approach rather than developing a system in a conventional programming languages. So some of the application which is required by, for example, if you take it a medical reception, medical shop, so software where in the medical shop is to issue a there is a as per as prescription, you issue a tablets or medicine. So there is no need of changing any requirement in the there is medical shops. So whereas there you can make use of the there is software which is, or a tool which is already developed. There is something like a, it's not a generic product, it's something like it's a generic product, not a customized product. So there you can just buy the product. So there is no need of to design once again in some other programming languages, which is no user. So ultimately the user has to make use of the software for there is a distribution of the prescription or there is medicine to the customer. That's the main intention or the main focus of the in the medical shop. So why do you require once again to be designed in some other languages which is make you cost more and which takes a lot of time? There is no use at all. So just the such type of software product you can buy it generic product itself. So it's a wide range of domains. It's now possible to buy off the shelf system, that is which is already there in the market. You can directly purchase that. That can be adopted and tailored to the user requirement. When you develop an application in this way, the design process becomes concerned with how to use the configuration features of the system to deliver the system requirement. So if you are in this type of, there is a buy off the shelf systems, there is a main intention here. The design process becomes concerned with how to use the configuration feature. So depend, for example, you may design the product for the Unix platform. So that same product that is required by the customer, but he is required in the Windows or some other platform. So whereas it is not supports the that is product which was developed for the Unix. So then we have to do some configuration as per as customer requirements. So a configuration feature of the system has to be delivered as to the system requirement as per as customer requirements. So this is what the build or buy of the software or implementation team. So object oriented design process. So in the object first, here also once again we are coming with the same concept of object oriented design. What we have seen here, structured objects oriented design process involve number of different system models. They require lot of effort for development and maintenance of these models. However, large system developed by the groups design models are important communication mechanism. Is a something like object oriented system is a interacting objects that maintain their own state and operation on the software or system. Representation of the state is private and cannot be accessed directly from the outside the object. Object oriented something design process involves designing the object classes and the relationship between the design of the program. To develop a system design from the concept that is design, there are several things that you need to do. What are that? Let's see. One is defining the context and modes of the use of the system, design the architecture, identify the principal objects, develop a models and specify the object interfaces. One is define the context and model of use of system, design the system architecture, identify the principal system objects, develop design model and specify the interfaces. So these are the object orientation design process that depends on the using the process, and process illustrates here using a design for weather, the wilderness weather station, what we have seen in the first topic or first module of the of this course. So context, system context and interactions. So understanding the relationships between software that is being designed and its external environment is essential for deciding how to provide the required functionality and how to structure the system to communicate with its environment. Understanding the relationships between the software that is designed and its external environment is essential for deciding how to provide the required system functionality and how to structure the system to communicate with its environment. Understanding of the context also lets you to establish the boundaries of the system. So a context diagram is nothing but and establishing the boundaries of the system. So the previous examples of the mental health care management system, medical receptionist and patient information, doctor appointment, etc. All the boundaries is required for the mental health care management system. Setting the system boundaries helps you to decide what features are implemented in the system design and features are associated with the systems come to know in the context and interaction of the system. Understanding of the context also lets you to establish the boundaries of the system. Setting the system boundaries helps you to decide what features are to be implemented in the system and what features are associated with the other systems are come to know in the context diagram of the system. Context and interaction models continuation of the is a structural model that demonstrates the other system in the environment of the system being developed. An interaction model is dynamic model that shows how the system interacts with its environment as it uses. So interaction models, you know, is there are use case diagram as well as sequential diagram is a dynamic model that shows how the system interacts with its environment. So here we can see the context diagram of the weather station. Here the association one-to-one association, one-to-many association. You can see control system, weather station, satellite, weather information system. So control system will pass there will be only one control system, but weather station there will be multiples of weather station, and satellite also we have one satellite where it gets collects a number of information from number of weather station, and here also weather information system will be having only one weather information system. So this is what the context diagram for the weather station, where it discuss about the external as well as internal boundaries. Main thing is they concentrate on the external boundaries of the system. So weather station use case diagram, you can see there is weather station two actor. One is weather stay information system and control system. So weather information system, it has two use cases. One is report weather and report status of the weather, and control system, that is system where it can restart, it can shut down, reconfigure, power save as well as remote control are the use cases for the control system. So use cases, it gives a tabular column what the actor as well as description of the use cases. Use cases is a diagram is of report weather. Actors are weather information system as well as control system are the two actors. Description of that is the weather station sends a summary of the weather data that has been collected from the instruments in the collection period to the weather information system. The data sent are the maximum, minimum and average ground and air temperatures. The maximum, minimum and average air pressures, the maximum, minimum, average wind speeds, the total rainfall and wind directions are the 5 minutes interval. Every 5 minutes interval, the wind at which direction it flows, all those informations are being collected by the weather information system as well as control system. And stimulus, the weather information system establishes a satellite communication link with weather station and requests the transmission of the data. So response, the summarized data is sent to the weather information system. So commands, weather stations are usually asked to report once per hour, but this frequency may differ from one station to another and modified in the future. So this is what the tabular column description given for the use case diagram for the weather station or weather station use case diagram. So coming to the next topic is a architectural design. So in the architectural design is the interaction between the system and its environment have been understood. Who use this information for designing the architecture? You identify the major components that make up the system and their interactions, and they may organize the component using an architectural pattern such as layer or a client server model. The weather station is composed of subsystems that communicate by messages on a common infrastructures. So you can see the architecture of the weather station. You have a fault manager, configuration manager, power manager, and you can see this is subsystem, is a package. Here fault manager, you have a number of components or subcomponents are being attached. Here they have shown the main components of the system, and communication, data collection and instruments. So the middle one is a communication link between all the architecture of weather station. That's all the sub or sub packages of the weather station system. And the weather station is composed of independent subsystems that communicate by the broadcast messages. Each subsystem listen for the messages on the infrastructure, that is messages from the infrastructures, and pick up the messages. It picks up the messages from the intended, and this is commonly used as a architectural style. When the communication subsystem receives the command such as shutdown or maybe command like pick up with the other subsystems, or then shut down themselves correct way, or key benefits of the architecture, easy to support the configuration of the subsystem. And sender of a message does not need the address messages to the particular subsystem. So these are the architecture that is what we see in the weather station, and this communication link will receive the messages or command from all the subsystem for the operate of the weather station. Architecture of the data collection system. See, in the previous slide, in the data collection we have seen that is number of subsystem like file fault manager, configuration manager, power manager, instruments, data collection and communication. And now they've given some brief about the data collection, what it actually does. Here we have see some subcomponents of data collection: transmitter, receiver, and weather data. That is, transmitter and the receiver are the objects concerned with the communication, and the weather data object encapsulate the information that is collected from the instruments as well as transmit to the weather information system. So this shows the producer consumer pattern. So transmitter transmits the data to the that is weather station. Receiver receives the data from the main weather station, and what it receives the weather data and it transmits to the main that is communication link, or it sends to the where the data processing of the weather, where the weather it performs. It takes data to the where it going to perform the data processing or computation take places. So where they can predict the weather condition of the places and sends the signal to the communication link. And object class identification, you have object class identification and is often different parts of the object-oriented design. There is no magic formula for object identification. There is no magic formula. You can give as you wish. As you wish, you can give the name of the object and domain knowledge of the system designer. Object orientation is a iterative process. You are unlikely to get it right first time. It's a iterative processes, and this is what very important for the examination point of view also, my students. They may ask how to identify the object classes in object oriented system. What are the steps are used to identify the object classes in the object oriented system? Or what are the approaches are used to identify the object classes in object oriented system? So here you can see one is use the grammatical approach based on natural language description of the system, which is used in the object oriented design method. Once again I say, use a grammatical approach based on natural language description of the system. Grammatical approach, something like it, which is writing like English simple statement. That is what natural languages description of the system. For example, they may ask, what's your name? My name is so and so. So this is what natural languages. So one is grammatical approach based on natural languages, and second one is a base the identification on tangible things in the application domain. So base the identification of an object based on the tangible things in the application domain, and something like how we are going to define the objects. For example, you can define the object something for if it's related to the aeroplane, aircraft, and if it is dependent upon any of the medical field, how are we going to define the object? Doctor, nurse, medical receptionist, manager, something like that. Events such as requesting event, interaction with the patient as well as doctor, such type of things are being used in the object oriented domain or object oriented classes. Use a behavioral approach and identify the object based on what participates in what behavior. So use a behavioral approach and identify the objects based on what participates in the what behavior. So it's always better to give a proper name for an object based on the behavior of the participants. So for example, if it's a mental health care management system, what is required actually? One is patient information, and to view the patient information, the nurse or receptionist is required, and to view the history of the patient, doctor is required. So this is what how you are going to identify the objects of the system is very important. Use a scenario based analysis. The objects, attributes, method in each scenario are identified. So it is always better to identify the attributes, operations, and objects based on the scenarios of the system. And these are the how is used to identify the object classes in object-oriented system, and very important question for the examination point of view also. So weather station description. A weather station is a package of software controlled instruments which collects the data, performs some data processing, and transmit this data for the processing. Instruments include air, ground thermometer, and anemometer, wind vane, barometer, and rain gauge. These are the instruments are used to collect the information from the weather station. Data is collected periodically. For a certain period of time, the alarm is set to collect the data from the station. When a command is issued to transmit the weather data, the weather station processes and summarizes the collected data. The summarized data is transmitted to mapping a computer when request is received. Weather station object classes. Object class identification in the weather station system may be based on the tangible hardware and data in the system. Ground thermometer, anemometer, barometer. Application domain object, there are hardware objects related to the instruments in the system, weather station, and weather data. Weather data encapsulates summarized data from the instruments. So weather station object classes. So this is what the weather station object classes. You can see the class name weather station, weather data, and these are the objects or attributes declared in the weather data as well as weather station. And ground thermometer, anemometer, and barometers are all the class diagram or class name of the weather station. And these are all the objects or attributes declared, and this is a function declared to the respective class diagram. So by this I will stop this online session of the module 3 6th video session, and the contents are taken from the software engineering Ian Somerville author, and if you have any doubt you can ask in the online video session. Thank you all.